Hello, my name is David Ackerman, student number 220-310-629, and this is the week 4 video assignment. Let's get started. So this is the problem that we're given. This is the givens where the plate thickness is 200 millimeters and transferring that is 0.2 meters. Half the thickness would be divided that by 2, so we're taking that as the L. These are the properties. K equals 20. Alpha, the temperature initial, temperature infinity of the outside, um, H and T. The time is 3 minutes, converted that is 180 seconds. The assumptions before we start the problem are 1D heat conduct, the constant property, so there's no change in neglecting these. No initial heat generation, and the radiation heat transfer is neglected. To start, this is a diagram of the whole problem, where it's listed with the H and T infinity right here, which is the outside. Length is 0.1, and inside we're taking X as equal to 0, which is the wall boundary condition. So the analysis, we're calculating PCP, which is a heat constant, which ends up being 3.57 times 10 to the 6. We're calculating Bayes' number using this formula, and we find that is 0.5. We're finding Fourier's number, and we're finding theta I, which is by this formula, which is 310. So part A is the lumped system analysis given by this equation right here. We for slab V of the air function of area of 0.2, which is the L. We're taking AS equals to 2A, and we're substituting every number into the equation, and then we are using this formula, these two formulas, right, this formula right here, into right here. So T infinity plus this number right here that we calculated given this formula here times 310 from here equals 309 0.75. So at 103 minutes, TS should be 309.75. Point B is the analytical term approximation given by this formula here. The condition that lambda 1 tam lambda 1 equals bi. So if bi equals 0.5, we can compute that lambda 1 should be 0.65. Using this formula here to right here, we're isolating for area 1, or for A1, which is 1.0701. Plug in every number here. Using this formula, we find it here. Plug in every number and plug it into the same formula as we did this previous time. We get that TS equals 267.34. And finally, for part C, the one-dimensional semi-solid analysis, the surface is x equals 0. Using this formula here, which is what we have been doing through all of it, and using this formula and taking B equals this formula, plugging in every number that we know, we get this number, plug in B back into this formula here. For these two B's, we get this number, and yet again use the same formula, get that TS equals 276.44 at 3 minutes. This has been my video. Thank you so much for listening.